From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 408, recorded live Thursday, January 23rd, 2014. This episode of Hansel Minutes is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, makers of GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Rodney Rehm about Sass.js.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I'm on with Rodney Rehm. Rehm? How do you say your last name, sir?
Rehm.
So that's exactly what I said. I'm on with Skype. You're in Germany right now, and I'm actually going to be in Germany in a couple of weeks, so we'll have to hang out.
Oh, great. Where are you staying?
Let me see. The name is it's Basta.net, and the name of the hotel is and see, here's another German word. I'm a lousy German here. Maritime Rhein-Main Hotel in Darmstadt.
Maritime Rhein-Main Hotel in Darmstadt.
Hotel in Darmstadt. Yes. I'm sorry. I'm a lousy German. For someone with a German last name, I have no German language abilities at all.
You know what's quite hilarious about that hotel?
What's that?
That's the hotel I live in.
First, you live in a hotel. That's pretty awesome.
Depends.
Yeah.
But yeah, I live in a hotel 5 days a week.
Oh, okay, because you work there, because you kind of commute.
Exactly.
Okay. And you live in this hotel?
In that very hotel.
So I'm going to present at a conference in your hotel. That's awesome.
Yes.
That's very Donald Trump.
Quite a coincidence.
Okay, well then we'll have to have you come and hang out. And then, gosh, you should be speaking at this conference, frankly. That way you would just go downstairs and present. I'm just saying, we could hook that up, right?
Maybe.
No, you don't want to go downstairs to present at the conference?
No, that's like the first floor. You know, I live on the 7th. I don't go down to the first floor all that often. Nah.
Yes, you're not going to slum with us on the first floor. So you work at Deutsche Telekom, and you're a front-end web developer?
Yep.
And you've got some really great stuff on your GitHub. I enjoy wandering around and kind of like low-key stalking people's GitHub accounts and checking out what they're committing on. And it looks here like a week or two ago you did something called sass.js. You basically compiled libsass to JavaScript the other week. Is that correct?
Yep.
Can we break this down into a couple pieces here? Because I think that some of the folks that listen to my show focus on Windows a little bit more than on Linux and JavaScript and kind of Mac tools. So they may or may not be familiar with some of these different tools that plug in together. Now, is this Sass and less than Sass? We think of those things as like less than Sass?
It's the JavaScript, sorry. The CSS precompiler Sass. Yes.
Okay. And less and Sass are kind of competitors, would you say? Is that true?
Yes.
Why are they always said? But why are they always said like as if they're one thing? Why do people always go less and Sass, less and Sass?
Because it's what they really think about is the idea of pre-processing the CSS, having some sort of secondary syntax to actually generate the CSS.
Mm-hmm. And the existence of tools like this, the idea that you need a precompiler for CSS, do you think that that's a vote of no confidence against CSS itself? Is this a way of us saying CSS doesn't do what we need it to do? It's not a good spec, so we're going to change it?
No, definitely not.
Okay.
It's more a manifestation of us developers being lazy. We like to automate things. We don't like to repeat ourselves. We like to write terse scripts instead of the verbose stuff a browser would need.
Mm-hmm.
So that's the reason we created those tools.
Do you think that that's something that people just have to do? I mean, because it seems to me that you could sit down and write front-end web apps with raw vanilla JavaScript and regular old CSS, but But any large system inevitably has a CSS precompiler and very often has something like CoffeeScript or TypeScript or something that compiles or transpiles to JavaScript. So we no longer are okay with just using the stuff the browser gave us. We feel like we have to step back a level. We've done this not just with Sass, but also with JavaScript itself. This is just all laziness that drives that.
In a way, yes, I think so. I like to write vanilla JavaScript, so I'm not going to bitch about CoffeeScript and that stuff all too much. But when it comes to CSS, using a precompiler such as Sass allows me to structure my code much more efficiently. I can use multiple files and have that processed at some build step into one single file. Now, I want to send a single file to the browser because of the network overhead, right? But I don't want to develop in one single file. Also, I would like to break down structures, like more complex CSS selectors. I would like to not repeat them all the time, but reuse stuff. Declare variables and use those values instead of having to write the same hex code for the same color all over my CSS. So that's the reason we use these tools.
And do you think that one of them will win, like in that way that jQuery kind of arguably won? You know, before we had more standards-based internet, when we needed jQuery to exist, jQuery kind of won. Do you think that Less and Sass one of them will become the de facto one that everyone will use, or will there always be different precompilers?
Honestly, I have no idea. I've never used Less, I've never used Stylus or Myth or any of the other tools. The only thing I've used is vanilla CSS and Sass. Does it really matter?
Yeah, that's a good point.
Because, our standards are evolving. One of the key reasons to use a precompiler is to have variables. Like the thing not to repeat yourself with color definitions or font sizes or whatever. That's like, have one spot where you tweak a value and it reflects throughout the whole CSS file. That is stuff we're going to get natively in CSS as well. It's the CSS values. They're called differently. They're I don't remember. CSS values.
Sure.
Variables. Whatever. They will come to the browser and they will be much more powerful than what the CSS preprocessors can offer us today. But that's 10 years away from actually being usable.
Right. It's definitely fun to see the kinds of exploration that people do and the kinds of hacking that people do that is all as a response to the web standards bodies not moving fast enough. Basically, the internet's going to make it happen, whether the web standards people make it happen or not.
Yes, there has been a shift in thinking, actually. It used to be the way that they write standards and we use them. Now we've reached a point where we can actually create our own tools and have the standards bodies copy them. It's like in JavaScript, you have the query selector nowadays, right? There's this function where you can pop in a CSS selector and get a bunch of DOM nodes out of it. That is the standards replication of jQuery's Sizzle, the engine that John Resig wrote back in the days.
Right.
So that's how things are working out nowadays. We create stuff, we try out stuff, and whatever proves itself will be embodied in a standard at some point.
Yeah, and it's a much better way to do things other than waiting for a year or 2 or 3 for a standard to come out and then finding that the standard is somehow wanting, is unacceptable. we're trying different things, and the one that is the best, the one that rises to the top, presumably then becomes the de facto standard, and then in this case becomes an actual standard, which is a good thing.
Exactly.
So, you're saying Sass, like there's a Z in the front? Is that how we say this? I've been saying it wrong all these years.
I have no idea. We call it Sass.
Okay.
Sass.
So it was
Whatever.
originally written in Ruby, this pre-processing language for CSS. And then people have basically taken this kind of spec for Sass and ported it to different things. And what I think is fun about the thing that you did is that, so Sass was written originally in Ruby, and then people are making other implementations of this. And then libsass, you can see at libsass.org, is a C/C++ port of Sass. And that is, that implementation is up on GitHub, and I think it's maintained by Hampton Catlin. Then there's Node Sass, which allows you to do things like tell Node to call this native version. So there's bindings for that. And then what you've done is you've used a thing called Emscripten, and is this right? You compiled the libsass version to JavaScript?
Exactly.
And did you just do this because? Or, I mean, what is the value of this? Because this is a fascinating thing, because it's such a representative thing of all the little tools that we can plug in different ways to see what's good, what's bad, why we would want to do this, why we would want to do that.
Okay, so we were discussing running a Sass compiler in the browser.
Mm-hmm.
And to do that, we would need a JavaScript implementation of it.
Right.
Now, we didn't want to actually implement a Sass parser, because others have tried and they have failed in keeping it up to date. I mean, the sass.js implementation hasn't seen an update in 2 years. So that's not really going to work, especially not for people like us who are constantly working on things and don't really have the time to put into maintenance necessary to actually keep those projects alive. So what we wanted to do, besides checking out Emscripten, obviously, was make our lives easy. It's like I wanted to just press a button and get the newest libsass compiled to JavaScript and be done with it. Mm-hmm. It's like release a new version in 5 minutes. That was the goal.
Okay.
And that's what we did. Emscripten is a Mozilla project, and it's a compiler that translates LLVM to JavaScript.
Okay, LLVM is
I have no idea.
I think it's like lightweight virtual machine. I'll look it up.
So basically, the C++ code is translated to LLVM, and LLVM bytecode is translated to JavaScript. And Emscripten is a Python tool, I think.
Uh-huh.
And besides like translating the bytecode to JavaScript, which probably is quite easy, it has to do a bunch of things that aren't that easy, which is emulating the subsystems. It's like in C++, you can access the memory. It's like you can allocate, like, I don't know, 3 kilobytes of RAM to do whatever you want to do with it. Like, you get this address and you can manipulate the RAM directly. You can't do that in JavaScript. We don't have access like that.
Right.
So Emscripten provides an environment where it emulates memory. It does that by defining a typed array, which is one of the newer additions to JavaScript. Came in with the canvas, I think, which is it's simply a typed array doesn't take any values. It takes only values of a certain type.
Right. So it's a constrained array, right?
Exactly. You would say each value can have 32 bits. That'd be like a thing you can easily map to memory.
Right.
So that's the idea. To get blazing fast access, you need to dumb it down for the computer. Dumb it down.
So by constraining the types, by going against JavaScript, which is very type loose, for lack of a better way of phrasing it, by constraining it, you're more appropriately and more performantly simulating an actual typed array of bytes or of whatever. So LLVM. Which I guess doesn't really mean anything now, but originally meant low-level virtual machine, is this compiler infrastructure, this C++ compiler infrastructure that gives you the optimization of all of these different kinds of programs. And that is what Emscripten builds on top of. So then you're literally taking libsass, which is written in C++, and compiling it into is it fair to say, a style of JavaScript?
Well, I would call it a subset of JavaScript. It's JavaScript, all right, but it's only using a very specific part of the language.
Right. Okay.
There is very much of byte shifting, byte operations, bitwise operators in use. Mm-hmm. So you wouldn't write JavaScript like that.
So it's not what we call, it's not idiomatic JavaScript. You're not going to look at this and say, oh, I can totally see what they're doing here. It probably looks like it's minified.
No, you can't. No, forget it. It's cryptic stuff.
Yeah.
You can't make sense of it.
Okay.
But it's JavaScript, and it's a subset Mozilla calls ASM.
ASM.js.
Exactly. Which they, again, can compile in a way that can be run extremely fast. I think they're getting it down to 2 times native speed or something.
Wow!
So it's extremely fast. For JavaScript, it's blowing you away. And we just did with this C++ library libsass what Mozilla did with the Epic Citadel.
Yeah.
I think.
Yeah, you can see that at unrealengine.com/HTML5. It's basically the Citadel demo in the browser. I've seen it running at 60 frames a second. It's Unreal. It literally is Unreal. You're wandering around in a 3D world, and it's done entirely in JavaScript.
Well, actually, it's not done in JavaScript. It's done in C++.
Well, yes,
but
you're correct.
It's compiled to JavaScript so it can run in your browser.
Yes.
And that is the new black.
That is the new black. I love that. Yeah, I mean, like you corrected me appropriately. It's written in C++. It is thought about in C++, but the bytecode is this low-level subset of JavaScript. And, SpiderMonkey is this engine inside of Mozilla, and then OdinMonkey is this project name for this optimizing compiler. So what they do is they take this asm.js and they say, all right, if we know that we're targeting this subset of JavaScript, then we know this is what our goal is, we can optimize this JavaScript differently than the JavaScript that you write idiomatically. And that allows them to just optimize the hell out of it. It's really, really amazing. So then it makes sense that JavaScript really is the assembly language for the web at this point. I mean, it's the closest thing we have.
It's been called that quite a number of times, yes.
Do you think that that's okay? Like, is this just a bunch of experiments, or do you really think that this means that JavaScript and Silverlight and Java rather and Silverlight and Flash, these virtual machine plugins, are just no longer needed? We have a virtual machine. It's in the browser and it is JavaScript.
Yes. Yeah, I would say that. Our virtual machine for the web is JavaScript, definitely.
Mm-hmm. So then you went and you took the Emscripten libsass, the result of compiling libsass through this Emscripten library. And then what did you kind of wrap around it? You put this on a convenience API around it?
Yes. So what you get out of Emscripten is the environment and your C++ code in JavaScript. You can call it in a quite ugly way, actually. And I didn't want to use that, and I didn't want to distribute that. So we wrote a convenience API on top of it. especially since Emscripten, the Emscripten environment also provides a file system.
Mm-hmm.
So any C application, any C++ application that relies on a file system being present can actually run in the browser as well. And libsass or Sass can access other files. It can include or actually import other files. And I wanted that feature in the browser as well. So we used the simulated file system Emscripten gave us and just made it usable. It's just like one function call, write file, give it a name, give it some content, and that's it. Mm-hmm. Not hassle with is that directory really available? Do we need to create it? Are the permissions in order? Is whatever? No, it's just this very high level. Write it and be done with it.
Mm-hmm. So in Sass, you can go and say @import foo, and that'll do file system access, and it'll give you the flexibility, like you said before, to have different files and, a nice build system. And then the result is one CSS file. So are you saying that you map that file system access to URL access, to just HTTP access?
Not quite. We have a demo for that, but we didn't follow through with it because at some point we actually had to get back to our regular day jobs. But we did enable, or we created everything necessary to do just that. Mm-hmm. That you could link to one Sass file and it would just resolve every import it finds recursively, like it would do on the file system. We didn't implement it all the way through, but it's definitely possible.
And so the result of this now is that you've got both, the ability to go and say sass.compile, in JavaScript in the browser, either synchronously or asynchronously using workers. And what is the point of this? Like, to what end? Is this just an example, like a great example of how we can plug all the Lego pieces together that the world has given us into something different? Or what value do you think this provides? Like, how is this making your day job better?
Well, it doesn't. I mean, we're not using sass.js at the office. I created it to prove a point. I live on really crappy internet. I'm a web developer. I live on the internet, but my connection usually is quite bad. I live in a hotel. Hotel Wi-Fi usually sucks. So I fall back to my 3G, which usually sucks as well. And when I'm home, I have a 1 Mbit line, which sucks. So I'm very far away from the internet most of my not working day. Which means I don't like network latency all that much. I wanted to use tools like JSBin or JSFiddle or Dablet or whatever you name it, and not send everything I do to a central server, have it processed there and send the result back down to me, but have it processed in my browser. Because, I'm working on a freaking MacBook Pro. This thing has power. Why not use it?
So that's interesting. So the talk that I'm going to give in your hotel is going to talk about this idea that we're really not pushing the browser as much as we should. And I talk a little bit about this idea that there's a lot of machines and virtual machines in the cloud, whether it be Amazon or Azure or wherever we're hosting our stuff at. And we like to scale those virtual machines up on the back end, but I think we forget that we've got either dual or quad core machines on the client side. And if we assume, like we talked about a minute ago, that these are virtual machines, maybe we could push these machines a little more. Now, you've got a MacBook Pro. I've got an iPhone. How appropriate are solutions like this in an iPhone? Can I run Emscriptenized JavaScript on an iPhone and gain the benefits of that?
It will run. It just won't run as fast. So it really depends on what you're trying to achieve. if you want independence from the network, it's the only way to actually go. If you want to reduce the traffic on your backend, it's a trade-off, really. It's like, you can't reliably figure out what system the browser's running on. You can, but how much power it has.
That's an interesting point. I never thought about that. Like, I might, we have like responsive design and adaptive frameworks, but from a JavaScript perspective, like, for example, if you've got 2 megabytes of minified Emscripten JavaScript, you might want to know ahead of time whether this is going to a MacBook Pro or whether this is going to an iPhone or an old Android device, because it could destroy the device. It could be like smoke and fire coming out of the phone at this point.
Yes. Figuratively, yes.
Yeah.
A mobile browser can only take so much data because it only has so much RAM. I mean, my MacBook has 16 gigs of memory. Mm-hmm. I can do anything I want on this machine. But my iPhone, I'm not sure. Does it have a gig of memory?
Yeah, I think it's a gig. But even then, what's available to you, really?
Exactly. Even if you have a gig of memory on the device, how much memory does your browser have? And from that memory the browser has, how much memory is allowed for your website? It's like, it's really not that much. And you also need to keep in mind that every image you load is stored in memory as well. So there's not that much stuff to go around.
Mm-hmm. But at the same time, we still see websites, big corporate websites, that do sorting of lists of a couple of hundred items on the server side. Surely there must be some line in the sand that we can draw that says, yeah, if you're going to sort 500 or 600 items, bring that down as JavaScript and let the phone sort it, rather than send view state back to the server and sort it on a web farm and then bring the HTML back.
It really depends on the amount of data you're talking about, but preferably you would do sorting on the device, mm-hmm. not on a server. Unless you're talking like millions of records of things. If you're talking about hundreds, do it on the browser.
Yeah, absolutely. I always like using d3.js, and I try to see how far I can push D3 and things like it on the phone. Like I keep coming upon old websites that do reporting and stuff, and they either do the reporting and the charts in Flash, which of course does me no good on my phone, or they generate the PNG on the server side and then send me a custom PNG. And I think that using either D3 or some chart or some SVG-based chart engine inside of the phone is going to be much better than generating some huge PNG and then sending it across the wire. Like that's kind of my go-to example.
Not only that, consider what you can do with SVG. It's interactive. You can actually animate it. You can drill down into content. You can do all sorts of amazing stuff a PNG just can't.
That actually is a great point.
You just can't do that on your backend. You want that interactive stuff to happen in the browser, and if you've reached that point, there really is no way to do anything on the backend anymore.
Mm-hmm. Now, I know that you said that you'd like to do vanilla JavaScript. Do you write SVG yourself as well? Do you write vanilla SVG?
It really depends on what I'm doing. Mm-hmm. I would rather write SVG as a file than use some JavaScript library, mm-hmm. if I don't have to. But it really depends on, am I looking at an icon or something, or am I looking at a very complex structure that needs animation and stuff? Then there is no way around constructing the stuff in JavaScript.
Right. Well, people can learn more about the stuff that you've built, like URI.js and, Smarty template engine a while back, all up at medialize.github.com. I'm going to put all of this information in the show notes, as well as your really interesting blog post about why you did this sass.js, and in response to actually Leah Verou's kind of speculative tweet about, I wonder if there is a JavaScript version of Sass. And then you were apparently in the hotel room with your buddy, and you guys decided to just make it. And I thought that the blog post is a really interesting, as you call it, incident report about this exploration and why you did it. It's pretty fascinating reading. I'll put that in the show notes as well. Thanks for chatting with me today.
My pleasure.
This has been another episode of Hansel Minutes, and we'll see you again next week.